Now that we know how to simplify radicals, we need to take a look at radical operations. So we need to be able to add, subtract, multiply, and divide. Okay. So in order to add and subtract radicals, you need to identify and combine like terms, just like you would with any other expression, right? This means that the index and the radicand must be the same in order to identify that things are in fact like terms. So let's take a look at these sets of terms and identify, are they like radical terms or not? Okay, so looking at this first set, I see the radicand is a 5 and the radicand is a 5. So they have the same radicand, but this is a cube root and this is only a square root. So these are not like terms because they're not the same type of radical. One is a square root, one is a cube root. Oops, sorry, spelled that wrong. So these are not like terms, which means I would not be able to add or subtract them. Okay, now I take a look at B. Well, I look at the radicand is 9, the radicand is 9, the index is 3, the index is 3. So these are like terms. They are both cube roots, and they are both a cube root of 9. Okay, this is like having something like 4x and a 6x. The 4 and the 6 are just coefficients in front. They do not impact the ability to have like terms. Okay, now let's take a look at C. Well, when I look at the radicands are not the same. The index happens to match, but the radicand does not, okay? So I get to say that these are not like terms because I do not have the same radicands. Okay? So now we should be able to identify what are like terms, what are not like terms. The question then becomes, well, how do we add and subtract them? Well, same way we would any other terms. Once we can identify like terms, we can combine them together, okay? So many times the radicands need to be reduced in order to identify what terms are and are not like terms, okay? So we're going to simplify each of these. Now, 5 square root of 3. There are no perfect squares that go into 3, so that's going to stay just a 5 square root of 3, okay? And I've got plus 2, and I've got a cube root. Cube root of 81. Well, 81 is 27 times 3. And I'm using 27 because 27 is a perfect cube. All right? So now if I look at simplifying that, this part of it becomes a 3 cube root of 3. But there's a 2 out in front. So this is a multiplication thing. So this is going to become 6 cube root of 3. Now I need to keep my 5 square root of 3 involved. Okay, but I still have more radicals to reduce. So let's take a look at those. I've got minus 4 square root of 27. Well, 27, perfect square that goes into 27 is a 9. This is a 9 times 3. So then as far as simplifying that is concerned, simplifying this down, the square root of 9 is a 3. The square root of 3 I cannot do. So now I'm going to have minus 12 square root of 3. Okay. And then I'm going to take a look at, I've got minus 6 cube root of 3. But 3 is a prime number, so there are no factors there that are going to break this down for us. So I just need to carry it down. Okay. So I've simplified each individual term as much as possible. Now I want to try to identify any like terms. Well, I see a 5 square root of 3 here. Are there any other square root 3's? And there are. Right here, I have a negative 12 square root of 3. So if I have 5 square roots of 3 minus 12 square roots of 3, 5 minus 12 is negative 7. And then I have the square root of 3 left. It's just like if I had 5x minus 12x, I would get negative 7x. So the radical part won't change. Just the coefficient changed in front of it. Okay. And now I have like terms in 6 cube root of 3. And I have another 6 cube root of 3, but the other one's negative. Well, 6 minus 6 is 0. So those are going to just perfectly cross off and eliminate. I essentially have plus 0 cube root of 3. So this is, in fact, my final answer. All right. If you can add like terms with polynomials, you can add like terms with radicals. It follows the same rules.